Hi everyone, you are in the case study regarding a condition called hepatic encephalopathy. Let's see how biochemistry principles underlie this type of disease. Let's begin with general definition and case. Hepatic encephalopathy or HE is a collection of neurological disorders your nervous system diseases, which are caused by the dysfunction of the liver. More simply, your liver is not good to maintain nervous system functions. Here is the case of HE, of which the patients present neurological symptoms such as confusions, irritability, agitation, sleep disturbance, loss of consciousness, and cognitive impairment. It is due to alcoholic liver cirrhosis. He was fine till he had a big meal of protein diets, beef and chicken, and he was subsequently brought to the OPD section. Lactulose healed him well, and the doctor suggested to avoid high protein diets. As the liver is defected by alcohol consumption, so how alcohol affects the liver. Once intake, alcohol is metabolized through oxidative metabolism through alcohol dehydrogenase enzymes or ADH, producing acetaldehyde, which is an extremely toxic chemical, potentially damaging liver cells, and finally resulting in cirrhosis. Moreover, acetyl-CoA is a stable product of alcohol metabolism after aldehyde, and it is a precursor for fatty acid biosynthesis. Triglyceride is then accumulated and resulting in cirrhosis finally. Together, it causes liver dysfunction leading to hepatic encephalopathy. Once the liver is interrupted, the three main functions of the liver are impaired. The first function is to eliminate nitrogen waste in the form of urea from toxic substance ammonia from various sources such as diets, gut bacteria, and proteolysis of the body through amino acid catabolism via transamination and deamination. Once liver function is impaired, urea production is impossible, so the BUN marker is dropped while ammonia in the bloodstream is enriched above normal, so called the condition as hyperammonemia. The rise in blood ammonia, which can cross blood-brain barrier into brain cells and potentially harm neurons of the nervous system by two possible mechanisms. The first mechanism is that ammonia reduces cellular level of alpha-ketoglutarate, then blocking TCA cycle. This effect results in reduction of ATP production, so the cells lacks of ATP energy. The second mechanism is that ammonia enhances glutamine production inside the brain, causing high glutamine levels. Glutamine has high osmotic pressure, so the water moves towards the brain to cause cerebral edema. Another function of the liver is to conjugate bilirubin in the part of heme degradation for its secretion. Free bilirubin is accumulated in the blood and deposited in most tissues. Due to the bilirubin color, the deposited tissue appears yellow, so the condition is called jaundice. The third function of the liver is to synthesize albumin, a major blood protein in which the water can be held inside the blood vessels. Impaired functions of the liver not to produce albumin, Water in the blood vessel is leaked into tissue spaces, causing edema, which is detected with the pitting onto the skin, and the pit remains after release of pressure. In worst case, water can be leaked into abdominal cavity and could cause ascites. Control of dietary protein intake is strongly recommended for HE patients as for minimizing the production of ammonia from amino acid catabolism. Lactulose is a potential agent to prevent ammonia absorption in the colon, by which the gut bacteria convert lactulose into acetic as well as lactic acids. These acids increase acidity of the colon and change ammonia to ammonium ions, which is not absorbable and finally secreted in the feces.